Hi everybody! So today we're going to take a look at the Optical Ring Sight, and this was a piece of tech manufactured by Polaroid during World War II. The Optical Ring Sight ended up on a variety of anti-aircraft guns and naval guns during that conflict. And in more modern times, optical ring sights have been used to help aim cameras during skydiving, and have even made it to the moon, helping astronauts frame appropriately some of the most iconic photographs of the 20th century. And the reason why this is of interest to us as optical mineralogy folks is that the optical ring sight is actually made originally using calcite and then some other optical materials as well later. I decided to create this video after reading the book Rings of Fire, which is a great dive into the history of the optical ring sight and its creation at Polaroid. I enjoy books of this style, looking at science history, and this book delves into the entire supply chain it took to actually find optical calcite, mine optical calcite, and then turn it into these gun sights vital to the war effort. I reached out to Larry Hughes as well, and he was kind enough to allow me to use his figure for the various types of optical ring sights for this video. And to make all these various types of optical ring sights, what we're going to need are some linear polarizers, some circular polarizers, and some pieces of calcite with windows that allow us to view along the c-crystallographic axis. You can find the linear polarizers along with the calcite with appropriately oriented windows at the eBay store Snellius Minerals. And here are links as well to the educational videos on linear polarizers as well as windowed calcite. We haven't talked at all about circular polarizers, but they actually consist of a linear polarizer with the addition of a quarter wavelength plate. I'm not going to go into further detail about these here. Circular polarizers and their uses are certainly worth their own nerdy video at some point. There aren't any circular polarizers for sale on the Snellius Minerals eBay store either. However, Richard Knight helped me out with a great workaround, and that is that many modern 3D movie projections actually use this technology. In particular, glasses for the Real D 3D system use circular polarizers. The 3D viewing glasses that you get when you go to one of these movies actually have two dissimilar circular polarizers in them. In order to do the full variety of experiments in the video today, you'll have to harvest circular polarizers from at least 2 pairs of these glasses. And if you don't really want to go watch a whole bunch of 3D movies, what you can do instead is just purchase these glasses themselves off Amazon. They're pretty cheap. Now, let's start out our experiments today by taking a look at the various optical ring sights that we can generate using linear polarizers. Here we have a diffuse light source, and to that we'll add our first linear polarizer. Now the light reaching us is plane polarized, and in this case the linear polarizer is allowing light to pass in a north-south vibrational direction. We'll add on our windowed calcite next, and nothing too interesting happens until we add on our upper polarizer as well. Right now our linear polarizers have their vibrational directions aligned, and I'd actually like to start out this demonstration with crossed polarizers, so I'm going to rotate our upper polarizer 90 degrees. You can see the beginnings of a uniaxial optic axis interference figure develop here, and if you want to learn more about interference figures, I'd suggest the video Optical Mineralogy Improved Uniaxial Optic Axis Interference Figure. So the vibrational directions of our upper and lower polarizers are now perpendicular to one another, and I just need to actually reset the focus a bit on my camera here in order to generate a nice uniaxial optic axis interference figure. We've now actually created one of the ORS variants. This is the Type 03R ORS variant, and consists of a piece of calcite sandwiched between 2 linear polarizers with perpendicular vibrational directions. The other ORS variants using linear polarizers are actually pretty simple to derive from here. By rotating our upper polarizer about 45 degrees, will actually then generate type 05R. This variant consists of a piece of calcite sandwiched between two linear polarizers, having their vibration directions offset by about 45 degrees. And the third ORS variant using linear polarizers, type 04, is generated when we rotate our upper polarizer an additional 45 degrees, thereby aligning the vibrational directions of our linear polarizers so that they're parallel to one another. So that is effectively how the ORS variants based on linear polarizers are made. The different variants exist due to concerns over accuracy as well as how much light the sight actually cuts out. So for example, the first sight we did, the type 03, isn't really suitable at all for dim conditions because with the crossed polarizers, it's cutting out a whole bunch of light. Now let's take a look at our ORS variants based on circular polarizers. So we're back out to our diffuse light source, and we'll now bring in our circular polarizer that's been harvested from a pair of 3D movie glasses. We add in our windowed calcite sample, and now on top of that, we're going to bring in our other circular polarizer from the same set of 3D glasses. The two circular polarizers from the same set of 3D glasses are dissimilar to one another, and this is how they generate a 3D effect when you're using them to watch a movie. We'll take a moment now to adjust the focus on our camera here. After doing so, we end up generating the optical effect associated with the Type 2R optical ring sight. This effect has a nice bullseye center along with concentric rings of color expanding outward from the center. Just a quick note on the diagram here, our circular polarizers consist of a linear polarizer and a quarter wavelength plate. In the diagram, our linear polarizers and quarter wavelength plates are broken out into two components, but those components together make a circular polarizer. If you wanted to add even more minerals into what we were doing here, you could probably make a quarter wavelength plate out of materials such as muscovite mica. And the reason why our circular polarizers in this case are dissimilar is because our quarter wavelength plates have opposite fast and slow axes. The oriented muscovite mica plate video is a good place to go if you'd like to learn a bit more about this. Back to our Type 02R setup. This one appears to deviate just a little bit from the ideal. I'm not sure if that's actually because of my circular polarizers or if my calcite is just not quite perfectly cut for this operation. We'll now remove our upper circular polarizer and replace it with a like circular polarizer. So in this instance, you'd want either two left eye lenses or two right eye lenses harvested from the 3D glasses. We've now generated our last ORS type, Type 01R, and this is the variant that is shown on the front of the book, Rings of Fire. And it's also the most common variant that was produced by Polaroid, so if you have an ORS, you probably have this type. You can see that our version has just a wee bit of distortion, and once again, I'm not sure if that's more a fault with the calcite or the circular polarizers. So, a very speedy recap of what we did today. We talked about the different variants of optical ring sights produced by Polaroid during World War II, and how we can recreate these optical effects using calcite, linear polarizers, and circular polarizers. The Type 03R ORS consists of calcite and two linear polarizers with perpendicular vibrational directions. The Type 05R ORS consists of calcite and two linear polarizers with their vibrational directions at around 45 degrees to one another. And the Type 04R ORS consists of calcite and two linear polarizers with their vibrational directions parallel to one another. Switching over to ORS types with circular polarizers, the Type 02R ORS consists of calcite with two unlike circular polarizers, and the Type 01R ORS consists of calcite and two like circular polarizers. I hope you enjoyed the video today. If you want to purchase some linear polarizers or windowed calcite in order to try out these experiments on your own, you can do so from the eBay store, Snellius Minerals. In the case of the windowed calcite, I've noticed that if you want to build an ORS, the sort of aspect ratio of window to calcite is actually a little bit better if the windows are large, respectively. And so it may also be best just to reach out to me at snelliusminerals@gmail.com, and I can make sure you get a windowed calcite that's particularly good for making an ORS. Thank you again to Larry Hughes for allowing me to use some of his material from the book Rings of Fire. Here are the references that I used in the creation of today's video. Thank you again for watching, and have a great day.